So with that, we will move on to our next section. So this is, we're going to pivot to what we call the opportunities presentation by Matt Bush. He's the Ohio Federal Research Network Program Manager, and Marty Kress, who you've heard both of them here just recently, who is a Ohio Federal Research Network Senior Advisor. Excuse me. Our team has researched various opportunities across the federal and state agencies. So following this event, we'd like to offer proposal process navigation for teams who wish to pursue the funding opportunities that are going to be discussed here shortly. So presenting these research opportunities, as I mentioned, is Matt Bush. Before joining Parallax, Matt was the Principal Director of the Special Operations and Combating Terrorism Office at the Pentagon, and he is also a U.S. Army Reserve Intelligence Officer, currently supporting the Department of State with coordination of DoD operations and activities. And as mentioned, we have Marty Kress, who today serves as a senior consultant to Ohio State University faculty and staff, the Tanzanian Ministry of Water and Education, WorldServe International, the Alliance for a Climate Resilient Earth, and Parallax Advanced Research and the Ohio Federal Research Network. So Matt and Marty, thank you for putting together this next presentation, and I will turn it over to you.
Thank you, Mark, and thank you again to our panel. That was a phenomenal download of information and discussion. So keeping those insights in frame, providing a deep dive insight into a few opportunities. The purpose of the briefing today is to provide all of you enough information to get you started on building a team to go after some of these opportunities that are funded and going to be available or already available. So one thing, and I'll stress this also in the next slide, is please keep in mind that we want to hear from you throughout this brief and also afterwards. So over the next hour, we'll be going over these topic areas. First and foremost, again, please ask questions throughout. Do not feel like you have to wait till the end. Love for this to be a collaborative session. So I'll briefly touch on some U.S. government arrangements, as we sort of did with both Dr. McNichols and Dr. Arnold about the CRADIS and Space Act agreements. Those are different types of U.S. government business arrangements. Then we'll move to specific funding opportunities, and then identify who can help you. And then, as Mark or General Bartman noted, the process navigation way ahead. In the next week or two, we'll be setting up some follow-on meetings, depending on level of interest in each one of these identified funding opportunity areas, to help you all identify topic areas within these funding opportunities, build teams, and then build proposals. So moving on to the next slide. So this side, you'll see what's called the contracting cone, and it provides a list of contract types that the U.S. government uses. At the base of the cone, you'll see FAR, or Federal Acquisition Regulation based, or non-FAR. In the past few years, the government has increased the number of opportunities leveraging non-FAR based contract. What this means is that they have decreased bureaucracy. I'm sure we all love the government bureaucracy, but love it more when it's not directly impacting us. So the use of FAR or non-FAR contracting opportunities is significant. Things like you don't have to obtain an auditable or accounting system, so you don't have to track down to the minute detail that hopefully increases your bottom line and helps you do more R&D rather than focusing on the bureaucratic administrivia. So you can find this cone with clickable links on each one of the wedges at the website noted below. That's Defense Acquisition Universities. There's a lot of free resources on that website, so please feel free to take a look at that. It's a great resource. So pending any questions, I'll move to the next slide. All right. I wanted to expand a little bit more on the contracting cone and highlight that the government uses a number of contract funding mechanisms. So for example, here, FFP is firm fixed price, or T&M is time and materials. The non-FAR based contract types are more fluid and thus are not bound to specific funding mechanisms as the FAR based ones are. In the black box, you'll see some agreements that you may hear about or want to look into, like the Educational Partnership Agreement, or EPA. It's a great opportunity for educators to develop a relationship with a federal entity that's typically non-reimbursable, but provides support on both ends for things like facilities and testing and lab equipment access. And then you'll see in the top right, the prize competitions, which are significantly different, and I'll be discussing that on the next page. So pending any questions, we'll move on to the next slide. All right.
Matt, you do have a question on the fan slide.
Mm-hmm.
Go back just a moment. Question was, where do the OTAs and ARAs?
Yeah, so OTAs, or other transaction authorities, are under the non-FAR, the top wedge of the non-FAR. There's both research and prototype OTAs. And those are typically aligned to OTAs consortia, which there are well over 20 different types of consortia. Those are typically business-to-business contracting through the consortia, similar to how OFRN does it for the state of Ohio. These OTA consortia provide B2B contracting on behalf of the government. ARAs, those are similar to broad area announcements. I'm not exactly sure where they fit in this contracting cone, so I don't want to get myself in trouble in providing incorrect information, but the ARAs are very similar to broad area announcements. And one thing I'll also note here is commercial solutions, or CSOs, were reauthorized this year by Congress as a standing authorization for the Department of Defense to conduct research and development on commercial solutions. So the DoD will be pushing out broad area announcement like CSO opportunities. So if you have a commercial product but want to do R&D on that product, the government will be able to push out BAAs, or broad area announcements, that fund your commercial solution to then do R&D on that commercial solution. So that's a significant opportunity, and also those are all going to be firm fixed price. So significant opportunity for industry to build on their R&D capabilities. All right, moving on. Okay, so the U.S. government has been using prize competitions for a very long time. For example, the design of the Capitol building were implemented through prize competitions, and that's a U.S. Capitol building. So I start out with prize competitions here because the first deep dive topic that we have is a prize competition. On this slide, you also see the start of the framework of the 5 W's, or who, what, when, where, and why. For the who, I note which government entity is aligned to the slide, as well as eligibility. For what, I briefly described the mechanism of the opportunity. For when, I describe the timeline, where highlights the location that you can find additional information. For this one, challenge.gov, and why provides the focus areas or thrust or areas of interest, depending on how the agency defines their topics. Some highlights on this slide: prize competitions provide funding at the end of the work rather than contracting and then providing funding throughout the work. Funding can range anywhere from a few thousand to up to 50 million, although total funding for the competition is typically, you'll see on challenge.gov, typically below 5 million. Almost every prize competition gets listed on challenge.gov, which is somewhat analogous to sam.gov or grants.gov or inspires.gov, the NASA one. But it's specific, the challenge.gov is specific for prize competitions. And I also note that the government is prohibited by Congress from gaining an interest in the IP developed as part of the competition. So this is a way to fund your IP development. Now the government can always request for a government use license, but they cannot obtain a controlling or interest stake in your IP developed under this. So pending any questions, I'll move to our first deep dive topic. If is Dr. Saxtetter? Yep, there he is. All right,
Good morning,
over to you,
Matt.
Dr. Saxtetter.
Good. Well, good morning, everyone. And I'm really happy to be here. I've been working with OFRN for a couple of years, and I'm very excited about the opportunity of us doing a better job of integrating the innovation and entrepreneurial capabilities in the state of Ohio into what NASA is doing. So this is one area that Matt asked me to talk about. So to give a real quick background, NASA, as you might expect, has been investing in power systems that are used in space. And one thing that has evolved pretty recently, or in the last few years, I should say, is that in order to really create a capability for sustainable presence on the moon surface, the lunar surface, the capabilities that we need there are essentially very power hungry. They require, tens to hundreds of kilowatts on a relatively ongoing and continuous basis, and that's not something that we have done before. So for the last number of years, NASA has been making very substantial investments in creating power generation capability that can support that level of activity, particularly on the moon and eventually, of course, on Mars. What NASA has not been doing nearly so much is to make investments in large-scale energy storage devices, say like batteries and fuel cells, because there is immense sector to do that, for things like surface transportation and all kinds of other uses. And so NASA is basically paying attention to what's going on in industry in that area. And hopefully, as time goes on, NASA will be able to simply buy what we need from that kind of capability. And by letting private industry do that, of course, that drives down the actual cost, and we're seeing that happen across the industry. But now, as we get closer to wanting to establish a continuous or eventually continuous and sustainable lunar surface exploration, we need power system capabilities that are also compatible with the much harsher surface. So this challenge called Watts on the Moon, I wish I had thought of it, but I can't take credit for that, is an intention to try to tap into what has been going on in industry and in universities and entrepreneurial organizations to extend the capabilities for power distribution and energy storage, but with a focus on extreme environments. And in particular, the extreme environment we're talking about is extreme cold, like 300 degrees minus F. I tend to, the numbers are more easily remembered when you talk about absolute temperatures. It's like 40 degrees Kelvin in the bottom of these lunar craters where the water is hiding. So the background picture here, by the way, is a view of the Shackleton crater, and one of these little minor craters on the rim is the location of the moon's south pole. Just a little fun fact about the image here. So the Watts on the Moon, attempting to benefit from what's going on in industry and in academia, we are really focused. It's a challenge. So the first deadline is June 15th, but that is not a deadline for a proposal. That is a deadline for an actual piece of work that has matured to a particular level. And so there's no funding available for people to participate in this to begin work, but rather people do their own work with their resources and compete for prize money that is awarded. Now, we also also realize that some of the people that may be able to contribute substantial innovation here may not have deep pockets. They just have great ideas. And so because of that, the challenge was structured to have interim levels of competition, which would themselves have cash prizes. And so the competition is separated into 3 levels. The first level, which is the submission is due June 15th, it's essentially what NASA refers to as a preliminary design. And when you look at the rules of the competition, you'd find out what that is. That level 1 competition will have up to 7 winners, and each of those winners will receive a cash prize of $200K and then be eligible to progress to level 2. Level 2 is comparable to a NASA critical design review, and that is due in February of next year. But in addition to submission of a design review package, we will also make site visits to the competitor's location to observe testing of prototype hardware to show performance in an ambient environment. And the outcome of that competition, there will be 4 teams that each receive a cash prize of $400,000 and then be eligible to progress to level 3. Level 3 is the big time. And at level 3, the up to 4 teams will bring their hardware to a NASA testing facility where it will be installed in a lunar environment thermal vacuum chamber beginning in about April of 24. And those prototype systems will be exposed to cold vacuum and actually need to, perform over the course of a 50-hour timeline. The best teams based on the lowest mass and affected by efficiency, the grand prize winner will receive $1 million and one runner-up $500,000. So we've structured this to kind of help people self-fund as they go through the levels of the competition, but culminating in a prototype device that would be suitable for further development to use on the moon. So Matt, next slide, please. So I have a couple of very quick slides. I'm not going to go through them in detail, but this kind of shows a schematic of what happens in the final testing where a power transmission device that's provided has to transmit power over some distance to a receiving power system where there is a substantial energy storage capability, and then the system has to then provide power to a NASA load. All of the power comes from a NASA power supply, and the power supply and the load are located outside this thermal vacuum chamber. So the devices will be exposed to a cold wall of liquid nitrogen. So it will be, exposed to a radiative environment of like 77 Kelvin. Not quite as cold as it is in the lunar craters, but it's way harder to get to 40 Kelvin than it is to do liquid nitrogen. So this is a schematic of what it looks like. And next slide, please. Thank you, Matt. This is the power timeline that the prototypes are expected to perform over the course of 50 hours. So the green areas are where there is power transmission or power made available to the system from the NASA source. And then the areas that are just blue the load has to be provided from energy storage. So I'm not going into much detail here for interested parties. There is a website that you can go to learn the details and the rules for participating. So last slide, please, Matt. So in quick summary, the intention was for the Watts on the Moon challenge to attract great ideas from the private sector. We anticipate, as has happened in many earlier NASA challenges, that there could be substantial participation from academic institutions, often partnering with entrepreneurial small businesses. That seems to be a pretty common theme in a lot of these challenges. but we're hoping to benefit from the innovation that can go on in those organizations outside of NASA, and to allow you to do your own investigating to learn more. NASA has engaged a private firm that has expertise in managing large challenges. It's called HeroX, and the website is indicated on the slide here. On that site, they have the rules. That is where you would register to participate, where you would demonstrate your eligibility, and you know, all of the things that are needed to administer the challenge. On that site also is essentially a blog, but where questions are posed and then answered by the NASA technical team. So that, and it's important that questions of any consequence go through that site, because, for example, today I can't answer any questions about, well, I have this great idea, what do you think of it? I can't answer that question because my answers have to be made available to anybody that has an interest. So although we may answer some questions today, for the most part, detailed questions would need to go through that site. And they will be answered promptly and with great expertise, since I'm the one responsible to answer them. A quick note, eligibility is limited to US-based entities, but as often arises when academic institutions are involved, there are provisions for non-US citizens or permanent or legal permanent residents to participate if they are associated with a US-based entity. So those rules are spelled out on the challenge website, and that's pretty standard for most government-funded challenges. And then finally, I want to first give my thanks and really encourage people to look into this. The Ohio Aerospace Institute has stepped up to taking on looking to encourage Ohio entities to be involved, and maybe as importantly, to help form teams, because there are different aspects of this challenge that one team may not be able to address alone, but properly teamed up with other entities may then find that they have a very strong possibility of making a credible entry. So with that, Matt, I will stop and let you manage any questions that may arise, or we wait till the end. So thank you for the opportunity to talk about this.
Thank you, Dr. Saxeter. So we'll pause for a moment and see if there's any questions from the group. Looks like you thoroughly informed everybody and there are no questions, but I'm sure
Very good.
As the day goes on, people, if they do have questions, again, go to the HeroX website and submit them directly through that website. Thank you, Dr. Saxeter, for your participation today, and looking forward to continuing to work with you, because NASA Glenn has a whole bunch of opportunity and potential that we need to do a better job from OFRN tapping into. So thank you.
Very good. Matt, I'll stay on the line in case there are questions about this or possibly other NASA things that I may be able to help with.
All right.
So thank you.
Thank you. All right.
Okay.
Next slide. So on a similar thread to Watts on the Moon, and potentially a way to build off of a team that's working towards Watts on the Moon, wanted to surface the Lunar Surface Technology Research, or LuSTR opportunity. So LuSTR is a grant out of the NASA Space Technology Mission Directorate. It has not yet been released for this year. So it's been released 2 times previously, and Congress did fund the program at a higher amount than requested for NASA for this year. And NASA did note that they wanted to increase the number of awards for this upcoming year. So it will come out. It's just a matter of when. And going off of the past 2 rounds, it was in July. So the LuSTR initiative is to support research and development and capabilities that support human exploration on the moon. So again, similarly tied to Watts on the moon. As you can see in the WHO, only US universities are eligible to be a prime, but industry and nonprofits are eligible and encouraged to participate as funded partners. And as similar as to what Kurt said, there's kind of a theme here. It's US entities, with the exception of one of the opportunities today, are the only ones eligible to submit. But non-US citizens or legal permanent residents can be part of a US entity team submission. One additional part, the last check mark there, if you participate in more than 2 submissions, all of the submissions that you are participating in could result in all of those proposals being non-compliant and thus ending your chance of gaining this opportunity. So the grant is a subset of Space Tech Ready NASA research announcement, which is somewhat analogous to the rest of the US government's BAAs with calls, where the research announcement is a chapeau BAA and LuSTR would be a call to that BAA. The timeline I have annotated on the top right is based off the last 2 rounds, as I said earlier, but may slightly change as we're going to see with the University Leadership Initiative. And NASA's typical timeline has gotten shifted to the right or delayed a little bit. In the where section, please note that NASA uses their Inspires website to upload documents that sometimes do not make their way to sam.gov or grants.gov. So it's always best to check Inspire for more information and create a profile in Inspire too. Future Opportunity Day will be going a little bit more in depth on Inspire. Thanks to Dr. Saxeter, he identified that if you create a profile in Inspire, you could actually be a judge or a reviewer on a panel of future solicitations. That could help you better understand the environment and the types of proposals that are coming into NASA. So again, we'll be going over those in a future OFRN Opportunity Day. On funding, it's fairly straightforward and there's no cost share requirement. It's up to $2 million over 2 years. And as noted on the slide, the intent of LuSTR initiatives is to support research for development of capabilities that can support human exploration on the moon. So I'll go a little bit over what that means in the next few slides. Before I do, I'd also like to highlight that Ohio State University won one of the first rounds of LuSTR awards. Just to give you a taste of what that was, OSU is exploring flexible energy distribution between multiple microgrids using solar, radioisotope, and battery sources, which will create and demonstrate a modular DC energy router that can not only function as a power flow controller, but also as an intelligent circuit breaker, realizing interconnections and power flow optimization between multiple lunar surface power systems. So that's a level of complexity that NASA is looking for LuSTR. Next slide. So LuSTR areas of interest align with the 6 Lunar Surface Innovation Initiatives, or LSII, focus areas that you see here, and I'll go over in more detail over the next few slides. But first I'll stop here and pause for any questions. All right. Hearing none, we will go to the first 2. Go to the next slide. All right, so in situ resource utilization, or ISRU, the goals include identifying current technology, critical challenges and technology development needs related to water, ice, and technology development and other materials in lunar permanent shadow regions, or PSRs, and extracting O2 and metals or metalloids from regolith in the illuminated terrain. For O2 and metals, current specific interest areas are oxygen and dry regolith that can be used for life support and for propellant. Metals and dry regolith can be used for construction, shielding, and as a rocket propellant. So again, this is really trying to use the materials in space and in situ to provide something that would take a lot of weight to get up into space. For water, water ice is in permanently shallow regions, as Dr. Saxeter noted, in the deep recesses of the craters, and offer potentially relatively easy to extract and process resource for human consumption and propellant, like hydrogen, and for things like hydrogen fuel cells. Then for value prospecting, the LSI team is mapping out the ecosystem of organizations that self-identify as part of a lunar economy and characterizing the products and services at a micro level. So there's a Google sheet that the LSI team uses where you can annotate your organization, capability area, and associated inputs, outputs, wastes, and functions. This Google sheet is open to the public, and if you'd like to obtain that, just shoot me an email and I will get that Google sheet linked to you. And then finally, modality and interoperability, which is a cross-focus group and bridges in situ, surface power, and excavation and construction focus areas. Specifically, this effort is working to identify modality, interoperability, and maintenance or repair needs, and approaches for ISRU technology, including the use of open architecture. I'll pause here and note that open architecture is a major theme across all of the US government. You'll see MOSA, modular open system architecture, or just open architecture, but that is a huge focus of the US government as a whole moving forward, trying to move away from proprietary solutions. Moving to surface power, this area is seeking to enable the right power and the right time at the right place. Pretty succinct, and it's almost any power that can be used in space. Includes power generation, such as fission surface power, adaptive lunar lander solar array systems, chemical heat integrated power source, and regenerative fuel cell energy. I know we have one individual who joined who is working on regenerative fuel cell energy concepts, so take note of that. The group will conduct a phased system level assessment of power architecture on lunar surface missions. And then additional topics going forward include surface to surface power beaming, sort of what Watts on the Moon is considering, advanced rover energy storage technology, again, also Watts on the Moon, radioisotope power systems, and power distribution architectures. They're also developing a power roadmap in the context of technology gaps as identified by NASA. So the third focus area of dust mitigation seeks to address a major challenge to robotic and human systems that impact the ability to enable a sustainable presence on the moon. The subtopics are fairly well defined, as noted here, and I won't be going into them in detail as they are so well defined and very straight to the point. But the high priority of investigation currently are surface stabilization, dust tolerant textiles, filtration, electromechanical, and magnetics, as well as dust mitigation structures. So pending any questions, we'll move to the next three focus areas. All right, extreme environments. These are technologies aligned to enable landers, rovers, manipulators, and other systems to operate through extreme conditions, such as rapid temperature changes and permanently shallow regions. Some examples of extreme environments include exogenic factors like illumination, communication, radiation, plasma, micrometeorites, and endogenic factors such as dust, surface toxicity, regolith, and rocks. For radiation environment, NASA is interested in ionizing radiation that can cause harmful biological and electrical effects. The ionizing radiation environment is made up of three sources that NASA is interested in: galactic cosmic rays that are emanating from naturally occurring elements, solar energetic particles emanating from sporadic sun events such as coronal mass ejections, and albedo secondary radiation that is produced by the above-two interaction in lunar soil, creating a flux of charged light ions and neutrons. Moving to the next Nope, go back. There you go. Regolith and surface interfaces is focused on properties of lunar regolith and its effect on our ability to survive and operate on the lunar surface. Again, this is one of those cross-functional areas with excavation and construction and in situ resource utilization. Space weather is focusing on definition of relevant environments, lunar sites of particular interest, nowcasting, forecasting, and sensing, modeling, and ground-based testing in laboratories. Thermal illumination and environment seeks to address significant variability of the lunar surface. For example, 140 Kelvin to 400 Kelvin temperature swings in the equator, power in permanently shadowed regions like Watts on the moon, and thermal management in persistently illuminated regions. And then vacuum exosphere environment addresses operational environment surrounding the moon that includes a molecular flow of atoms and particles that includes helium, nitrogen, hydrogen, argon, and other trace gases. So the lunar surface is more than just a vacuum. There's a whole bunch of potential particles that could affect systems. Some atoms are off-gassing from the moon itself, and others are contributed by solar winds. Thermal conditions and the lunar day and night cycle noticeably affect lunar exosphere as well. Extreme access is considering the needs of robust and sustainable surface activities such as bulk transport of regolith. Think of a supply convoy, or ingress, exploration, and egress of subsurface voids, hazard detection in all lunar environments and conditions, as well as communicating and navigating with minimal infrastructure and autonomous operations. Again, the subtopics here are fairly well defined as listed on this slide. The focus area includes lunar spectrum management, and NASA briefed on this capability back in December. That link is noted on the slide. Again, these slides will go out later today. Why I'm noting this one specifically is that the lunar mission landscape timeline is included in that briefing. So if you'd like to better understand the timeline that NASA has forecasted for NASA exploitation or exploration, it has it on that briefing. And then finally, excavation and construction. Relevant technologies of interest for this focus area include additive construction, autonomous construction, excavation tools for lunar conditions, sintering, regolith processing, etc. In situ repair and outfitting are other areas of focus. Similar to extreme access, the subtopics are fairly well defined by their title listed on the slide. The focus has 5 different cross-area connections. So this is another one that integrates with multiple focus areas, including power, in situ resource utilization, extreme environment, dust mitigation, and extreme access. This concludes the areas of interest for the LuSTR opportunity, but I'll be moving to next slide to discuss the Lunar Surface Innovation Consortium, or LSIC, that facilitates support for NASA across all of those focus areas that I just discussed. Their spring meeting, or the LSIC Consortia spring meeting, will discuss research across all focus areas and likely discuss LuSTR given the time frame that it's happening, which is May 4th, and LuSTR is usually announced in the June-July timeframe. So please note that research papers for this meeting were due earlier this month, so you can't inject research into this, but you can still register to participate online. It will be a hybrid event, both online and in person. So pending any questions, that concludes my brief on LuSTR. For more information, feel free to contact me or go to the page link annotated at the bottom of this slide. All right, hearing none. The next opportunity is NASA's University Leadership Initiative, or ULI. Similar to LuSTR, only US academic institutions can prime or be the PI of this opportunity. A little bit different than LuSTR is that this is funded by the Aeronautics Research Mission Directorate, meaning that it's focused on terrestrial applications. It annotates a difference between industry and nonprofit partners that are funded teammates or collaborators who are unfunded teammates. A business arrangement is a collaborative agreement, vice a grant. And then while cost share is not required, it is potentially going to be considered where LuSTR does not identify the need for or the intent to consider cost share. Looking at the timeline, NASA has been advertising this opportunity would be announced in March. As I noted earlier, that has shifted, so potentially in April. So be on the lookout for the official announcement. On the funding, this award is 3 years and provides between $3 to $6 million over 3 years. And then pending any questions on this, I'll move to the next slide to kind of describe what NASA's intent of this opportunity is. Hearing and seeing none, we'll go to the next slide. All right. So this slide again provides NASA's program description of the ULI, which they intended to be a multidisciplinary effort to commercialize research and provide opportunities for undergrad and grad research as part of this project. This is similar to where we are going with OFRN, as we've now included the C initiative, the Student Experiential Engagement Initiative, and intend OFRN funded projects to commercialize their research. One additional point to note, NASA is very interested in including partners and universities who had not previously received NASA aeronautics research funding. So part of the leadership aspect of this is a organization that has ARMD experience shepherding those schools that do not have ARMD experience on the team. So that typically gets more weight in terms of the rating on the back end by NASA. All right, pending any questions, we'll move on to the next slide. All right, so similar to what was briefed earlier on the NASA ARMD strategic thrusts, the ULI must be aligned to one of the ARMD areas listed here, which are the strategic thrusts. And as noted earlier in today, NASA Glenn is also specifically integrated in the ultra efficient subsonics, as well as innovation in commercial subsonic aircraft. So I'll go over the specific strategic thrusts in the next slide, but we'll wait here, see if there's any questions. All right, hearing none, moving to the next slide, please. So safe, efficient growth and global operations traces to modernizing the air transportation system through next gen to achieve much more capacity and operational efficiency while improving safety and other performance measures. ARMD is seeking to contribute specific research and technology to enable the continued development of next gen and beyond to achieve safe, scalable, routine, high-tempo airspace access for all users. ARMD is also working with the advanced air mobility or urban air mobility ecosystem, developing concepts to enable a safe, scalable system and growth of this new transportation sector, which is very much aligned with what OFRN has funded over the past 3 years. Projected growth in air travel will require sustained focus on reducing risk and maintain an acceptable level of safety. To that end, ARMD is working with FAA and Commercial Aviation Safety Team and others to perform research and contribute technology that addresses current and future safety risks. So moving on to innovation in commercial supersonic aircraft. That strategic thrust is seeking to support development of efficient, cost-effective, and environmentally compatible commercial supersonic transports that could be a game changer for transcontinental and intercontinental transportation, providing an opportunity to maintain U.S. leadership in aviation systems and generate economic and societal benefits in a globally linked world. In order to achieve the practical and affordable commercial supersonic air travel, ARMD has been focusing their research on advancing groundbreaking technologies like those discussed earlier today that overcome barriers to reducing its environmental impact and realizing innovative economic efficiencies. Since overcoming these barriers will likely involve modifications to regulations and certification standards, ARMD is also conducting research in cooperation with FAA, ICAO, and other aviation regulatory agencies. Pending any questions, I will move to the next two strategic thrusts. All right. Ultra-efficient subsonic transport seeks not only improvements in aircraft efficiency, but also reductions in noise and harmful emissions. ARMD is looking to enable sustainable efficiency gains along with fundamental shift to innovative alternative energy-based propulsion systems through the electrification of aircraft propulsion in combination with sustainable alternative jet fuels and renewable energy. ARMD is also working to enable substantial reductions in time and cost to market of aircraft through advanced materials, structures, manufacturing technologies, and enhanced digitalization of the full aircraft life cycle. One of those areas is the high rate composite additive manufacturing concept that they're starting to build. It's a new start for fiscal year 22. The next strategic thrust directly maps to advanced air mobility or urban air mobility, which are concepts that leverage cost-effective use of aviation, including advanced vertical takeoff and lift vehicles to provide options for using air travel as part of daily activities through unprecedented access and shorter door-to-door time compared to other modes of transportation, while also reducing infrastructure due to removing cars off the road. Well, this capacity is expected to greatly increase the demands for air service and significantly increase the number of flights. This mode of air travel will only be practical if the advanced VTOL aircraft acceptable level of safety while reducing its environmental footprint. So in-time system-wide security assurance, ISAA, is a safety net that utilizes system-wide information to provide alerting and mitigation strategies in time to address emerging risks. Moving forward, aviation safety needs to take advantage of modern information available and intelligent systems. New operational concepts will change and diversify aviation and create the need for advanced safety capabilities and operate on a broad scale. ISAA will incorporate both advanced technologies and collaboration between humans and intelligent agents. And ISAA will be both system-wide and distributed. Its vision is to predict, detect, and mitigate emerging safety risks throughout aviation system and operation. And then the final strategic thrust is assured autonomy for aviation transformation, which is seeking to address the risks associated with ever-increasing levels of automation and autonomy that are transforming aviation. ARMD is leading research and development of intelligent machine systems capable of operating in complex environments, including the safe integration of unmanned aerial systems into the National Aerospace System, or NAS. Complementary methods will provide safety assurance, verification, and validation of these systems, paving a way for increasing autonomy airspace and vehicles. ARMD is looking to explore human-machine teaming strategies, advanced metrics, models, test beds to evaluate autonomous systems in both laboratory and operational settings, and safely implement autonomy in aviation applications. You'll sometimes see the term secure and safe assured autonomy, S²A² or S2A2, as the new title for this strategic thrust. So this concludes the brief on ULI opportunity. For more information, again, feel free to contact me or go to the page linked at the bottom of the slide. I'll pause for any questions. All right, hearing none. Moving on. So the first Air Force opportunity is Manufacturing Research and Technology Broad Area Announcement, which the solicitation is open and out already. As discussed during the last opportunity day, this BAA is an open BAA, meaning that it has no defined due date for proposals. It is also a two-step, meaning prospective proposers would submit a white paper prior to a full proposal. And then similarly discussed during a prior OFRN opportunity day, it's important to contact the subject matter experts listed on the BAA prior to developing a white paper to discuss your concept, to just validate that it is potentially of interest. One point of note, the US Congress typically directs additional funding to AFRL Manufacturing Technology Program to fund specific projects beyond the executive branch request. So this you may hear as earmarks or member-directed spending is the new term for earmarks. But this directed funding or additional is could be used separately, where earmarks go directly no matter what to whoever they're directed to. These additional plus-ups can end up going elsewhere. But for the U.S. government fiscal year 2022, Congress appropriated $175 million for Air Force manufacturing technology, and Air Force had only requested $45 million. So a lot of congressionally directed spending diverted over to the Air Force Mantech program. At the bottom of this slide is a black bumper sticker. That's critical to Mantech proposals is the focus on manufacturing capability and the plan to mature that manufacturing readiness level of that manufacturing capability. With that said, I'll move on to the specific interest items of this solicitation. So call your attention to the graphic on the right side. Air Force Mantech program is seeking to fund manufacturing related technologies that are the blue horizon lines that specifically support technology capabilities annotated in the gray vertical lines. So if you have a manufacturing technology, it should map to supporting manufacturing capabilities that align to those technology areas that are in the gray. The opportunities linked to this challenge associated with the cross-cutting focus areas, manufacturing at speed, enabling production-ready prototypes rather in months rather than years, enhancing the agility and interoperability of the industrial base through digital infrastructure, and then enabling real-time comprehensive analysis of the industrial base. And those map directly to those three challenges noted on the left. Further homing in on potential interest of AFRL Mantech team prior to you engaging with them, while there is a digital manufacturing branch in AFRL RXM, which is the Mantech branch, it is the only branch. There is only one branch that has focus on software capabilities. The rest are hardware intensive. Their focus is on supporting tier 2 and tier 3 vendors, which is specifically important to them as it diversifies the industrial base and does not tie them in with a specific contractor or prime contractor. Also, there's interest in decreasing the costs and timelines related to composites for fighter-sized or larger aircraft and sensors at the subcomponent level. Again, looking to diversify their potential impact by focusing on subcomponent level rather than the sensor system as a whole. So this concludes the AFRL Mantech opportunity brief. If you'd like more information, feel free to contact me or go to the pages linked at the bottom of that past slide. So moving on to the Department of Homeland Security, or DHS, Long Range BAA. Next slide, please. The Long Range BAA is a direct applicable BAA to multiple capabilities funded or possessed or proposed to OFRN over the past few years. The opportunity is fairly regimented, as you'll see in the when to the bottom left, and they use contracts through a public-facing website, which is identified in the where, the first bullet. That website is similar to the Air Force Tech Connect website that we discussed during the last opportunity day, which is a more effective and efficient way for industry and academia to submit requests for engagement rather than sending multiple emails and phone calls trying to obtain a response from the government. The Tech Connect is linked at the backup of the slide deck. I don't have it here, but this oip.dhs.gov is similar to that Tech Connect, but for Department of Homeland Security. Different than all of the other opportunities discussed today is that this one is open to any entity, including foreign entities. Something to note about this opportunity, it supports S&T requirements across the Department of Homeland Security subcomponents, which include Custom Border Patrol, Immigration Customs Enforcement, U.S. Coast Guard, FEMA, U.S. Secret Service, TSA, everybody's favorite U.S. government entity, and then the Cybersecurity Infrastructure Security Agency. So a fairly wide-ranging set of sub-agencies that are linked to potential users or supporters of your capability through this funding opportunity. So I'll be going through two specific topics. There are, I think, over 10 different topics associated with this long-range BA. The first will be countering unmanned aerial systems, and the second will be air-based technologies, both of which are focusing on integrated and improved sensor systems and data, and both are interested across a number of the DHS components that I just mentioned. So next slide, please. And we're getting close to time. So the counter UAS, big focus here is they fund TRL-4, but have to have a plan of TRL-7 at the end of the project. They're focusing on Class 1 unmanned aircraft threats, and specifically detection, track, and identification, and across multiple different types of operational use cases, from maritime to border to ports to urban terrain. So Secret Service providing the support to the White House. So UASs that could be a threat to the White House, and countering those might be of capabilities addressing that might be of interest to this opportunity. Of particular note, beyond just BA or DHS, last week, an article quoted the Chief of Staff of the Army saying the Army is going to become more aggressive in acquiring weapon systems to take down lethal drones, and that the industry should develop solutions from directed energy, high-powered microwave, and missiles because the Army needs multiple options. And specifically stated, for those in the industry, this is a growth area. There will be something you want to consider in this. And for the Chief of Staff of the Army to say that, he's looking across the entire Army, which means significant dollars. Pending any questions, we'll move to the next slide. And this is the air-based technologies. So a focus here is really having an operational capability at the TRL-8 that can integrate with current DHS small UAS operational assets. And we can discuss with anybody of interest what those assets are. One of our funded teams, Asymmetric and Ironclad, is working and has worked significantly with DHS along those lines. So I'll go to the next opportunity. Next slide. This one, the description on it is probably, this is an RFI, so it doesn't provide any funding, but it can lead to further discussions with the Office of Director of National Intelligence. Their intent, where they are right now, ODNI is developing their S&T strategic investment framework, and responses to this RFI will help develop that. So it behooves you to help shape where ODNI wants to fund capabilities. And you do that through, go to the next slide. You do that through downloading the Excel that's noted here. The bullet points are the columns of the Excel. You first identify a need, then you map that to the capability estimate. and technology domains. And this slide deck goes over those, and you describe your proprietary or non-proprietary technology capability and how it maps to the technology need. The important part, go to the next slide, is identifying the intelligence need, which is on the bottom left. So the 2N011 is an example of intelligence need number. And then the technology domain for that is artificial intelligence, computing, cyber, data, and forensics. So then you take that artificial intelligence or cyber or data, then you go to the next slide, and then you map it to the technology domain, and then fill out the column P of the RFI, and then wherever your research is. This is just exemplar. There's also advanced research, commercial solutions, but you place where you annotate what level your research is at in column N. So then you go to the next slide. So this is just a blow up of the 3 columns that you pull information from, and then the rest are ones that you develop internally. And then you submit your completed Excel to the S&T investments at dni.gov. For more information on this, there's a webinar that's linked at the bottom of the slide, and feel free to go watch that. Next slide. All right, so I know we went over a lot today, and if you're interested in discussing potentially teaming for any of these opportunities, we'd love to host a Zoom meeting for any of those interested. So we'll be populating a poll right now. And if you're interested in any of the opportunities and teaming specifically after this discussion, please annotate which ones you're interested in, and then we'll contact you to set up a time that works for all those who had expressed interest in the identified opportunity in the next 1 to 2 weeks. So. All right.
Great, Matt, is that it?
That is it.
All right, awesome. That was fantastic. Thank you to both Matt and Marty. I want to thank, of course, all the speakers and attendees who joined us today. Hope that you've identified maybe an opportunity or two from across the Ohio research and development ecosystem that will help your team or company grow and innovate at the speed of business. We'll be hosting a follow-up meeting with select teams who are interested in pursuing the opportunities that were covered today. We're also offering team matchmaking and process navigation to help you put your best foot forward in the application process. The Ohio Federal Research Network team will be sending out an email with more information about that follow-up meeting soon after today's event. I think there might be one more slide that has a list of other events that are going on this year. I don't know, Emma, if you want to throw that up right now. Otherwise, we would love to be able to hear any opinions or ideas that you have for future opportunity days that the Ohio Federal Research Network will be putting on. So with that, we look forward to seeing everybody again at some point in the near future, and hope to maybe see you at one of these events in person. Thank you very much.